Hello everyone, welcome back to another video. Today we are going to continue on with covering some of the basics in Java, and today we will look into variables and expressions. So first we want to start off by connecting the dots. So why do we even need variables? Variables are basically used so you can remember information within your code. So things such as names, numbers, or even data values would all be considered or attached to a variable. So a variable is basically a named location in memory, but it's basically holding a value that you are going to be needing within your code. So to jump into that further, here we have an example of what I mean as a named location in memory. So you see to the left where it says in programming, int age equals 21. That's basically saying that age is going to hold the value of the number 21. Now, that value is then stored somewhere in memory or your RAM, and is basically placed there, and it will remain 21 until it is changed. So age is the variable name and 21 is the value of the variable name, and it will be stored again in your RAM until it is needed. So there are different parts of the variable. We covered it briefly in the last slide, but variables have a type, a name, and a value. So first we're going to start with the naming rules. So when it comes to naming a variable, you need to make sure that it's starting with the lowercase letter. Now this is just what it's called, or I guess it's like an unwritten rule of Java. It's just always trying to start naming anything with a lowercase letter due to another technique that you can use, which we will discuss later on. So it will start with a lowercase letter, and it can contain letters, numbers, underscores, and dollar signs within it, but it cannot have any spaces. And it is also case sensitive. So when I say case sensitive, this goes for pretty much most of the concepts in Java that are case sensitive. So if you remember back on the video where I covered program structures and speaking on the main method and how it had to match exactly what I showed you, that would be an example of case sensitive. So Java basically treats your uppercase and your lowercase letters as different characters. So when someone says case sensitive, they're basically saying that the spellings have to match exactly whenever you're creating or calling a variable. So if you look at the example we technically have the word name 3 times, but they are all technically displayed differently. So the first one's all lowercase, the second one has a uppercase N, and the third one is all capitalized. So if you were to make 3 variables called name in this way in your code, that would technically be 3 different variables, although they have the same exact spelling. So in Java, there is a case that we use where, let's say your variable name, you would like it to be more descriptive. Then you would use what we call camel casing. So camel casing is when you would use that capital letter to start a new word, but combine them. So it's like entering a space without having a space, and it makes it easier for you to read the name. So there are going to be times where, you want a variable that has a complex name. And camel casing comes in handy because when you're naming your variable, you're starting off with a lowercase letter. So when you add a new word to it, you would uppercase it, and that is what is called camel casing. hence camel is coming from the hump in the back of the camel. Basically, when you do a lowercase and then do an uppercase, it kind of creates a hump, and that is why it is known as camel casing. So if you look in these examples in the box, we have student name, we have total price, and we have account name. Now, basically, the concept of camel casing is that first word is going to be all lowercase, and that second word is going to come right after the first word, but it is going to be distinguished by a uppercase letter, which is camel casing. So if you see in student name, the N is the second word, the N is capitalized. In total price, the P is the second word, the P is capitalized, and in account name, the N is the second word and the N is capitalized. And that is basically how camel casing works. Because you cannot use a space between the two, you would do camel casing instead. So here are some examples of variables fully constructed. On the left, we have the good examples, and on the right are the bad. So basically, for the ones that are on the right, you want to avoid doing this. The ones on the left are good to go. So you see the first example in the good column has a camel casing case, which is fine. There's no spaces. It starts with a lowercase letter. Same with the second. Everything in that case is lowercase. Same with third. Over on the bad side, that first example starts off with a letter, and so does the second. That is why there is a problem there. You should not start with a number when creating variables. On the last example on the bad side, there is a space between total and price. So please remember, you cannot use spaces when creating a variable. That is why camel casing is a thing. Just use camel casing in that case. So when you're using variables in Java, you must declare them before using them. Basically saying they must be created before you use them. So to declare, also known as create a variable, first you would have to determine the type. And when I'm referring to a type, I mean what data type is it? Now we will cover the data types soon, but basically we're going to specify the type of data that variable is holding. Is it holding text? Is it holding a number value? What type of data is being stored? Once you determine the type, you then would follow the type with the name. Again, the name of the variable should represent whatever the data value is holding. So if it's someone's name, you would say name. If it's a number, you could say number. If it's a shirt type, you would, basically that's text. So shirt type, you would use camel casing. So the variable name really does not matter as long as it follows the variable naming rules. And then you would just end it with a semicolon. So declarations are basically known as statements, and they need a semicolon. So if you look in the examples box, here are 3 examples of variable declarations. So you basically state the data type, you state the name of that variable, end it with a semicolon. Data type, name, semicolon. Data type, name, semicolon. That's how a variable declaration works. Now, initializing a variable is when you will be assigning a value to a variable that has been declared. So on the last page, we declared a variable. On this page, we're showing you how to assign a value to a variable that's already been created. So if we look in the example, we see we have a declaration statement that says int age, and then the next line we're saying age is equal to 20. So initializing is basically saying this variable is equal to this value. So in this case, age is going to be 20. So anytime in your program that you type in age after this point, it's basically going to be replaced with the value of 20. But again, A lot of this is going to make sense once we get into the coding example. So when it comes to actually creating variables, you can take the route that I just showed you, which is declaring first and initializing second. But technically, the easier route would be option 2, and that would be to declare and initialize together. Now, in this case, both examples are doing the same thing. They're both creating the same variable, and they're both assigning it the same value. But there would be two different use cases for these options. So, for example, you would use option 1 if, for whatever reason, you know in your code that you will need to store a name, but you have not given the program the name yet, or you don't know what the name is. If that's the case, you would go with option 1. However, if you know exactly what the value is already, then it would make sense to go with option 2. So option 1 is typically if you don't know the value or you need to change the value a lot in the future. Option 2 is generally if you know what the value is and you don't really have a plan of changing it. So that leads to the point that your variable values can actually be changed once they're created. So to change a value of a variable, that's basically what we would call reassigning a variable, because you would be assigning the variable again, reassigning it a value. And that variable can change constantly throughout the program. So let's say at the beginning of the program, you just declare an age and then you enter that age is equal to 20. But then let's say later on in the program, you asked a user to input their age. And when that user inputs their age would then change from 20 to whatever they entered, and in this case, 10. So after that point, age will be 10, and basically the one that was holding the 20 would be replaced and no longer valid. So when it comes to reassigning a variable, once you reassign a variable, there is no way for it to become the previous value unless you reassign that value to the variable. So once the variables are created, you can actually print them or view them on your screen. And that would be done by using a statement we like to call the print statement, and that is system.out.println. And yes, case sensitive, meaning you have to type it in exactly like that for it to work, including the parentheses. So inside the parentheses of that statement, you would then place the variable name. So if you take a look at the example, we first declared the variable of age. Then we give the variable a value by initializing it. So basically at this point, age is holding 20. Then we have a print statement. The print statement will then print out the value that age is holding. So it will not print out the word age. It would print out whatever value age was assigned. In this case, this code would print out 20. So with variables, variables can be used in expressions. And expressions basically are used to produce another value. So generally, this would be used more so with like doing math operations. So if you want to add, so yes, you can do math in Java, similar to a normal calculator. But on the screen, you see all of those are examples of expressions because they are using math operators with them. So plus and multiplication, division, and subtraction, math operations. So variables can actually be used when you're doing math operations. So if you look in this example, if we created a variable that's called x and holds the value of 10, then we create an expression that we are going to say that x is now going to equal x times 2. So what happens with that, the second line, x equals x times 2, that will basically say that x is going to be reassigned to the value of the past x times 2. So the second line, or where it says expression 1, would then change the value of x to 20. Because remember, the equal sign is an assignment operator, meaning that it is going to assign the value on the left to whatever is on the right. So although we said that the line above that x was 10, now we're saying x equals again, and when we do that, that's basically changing the variable's value. So the second line will change the value of x from 10 to the new value. On the third line, or in expression 2, we are creating a whole nother variable called y, and now we're saying that y is going to use the new variable of x plus 5, and that will then be the value of y. So if that was a little confusing, I understand. Again, like I said, we're covering the concepts and logic first, and then we'll do the example so it'll make sense there. So between the last video of covering our overall programming structure and now covering variables and expressions, we are at a good spot where we can start diving into getting into the code. So actually going to NetBeans or whatever IDE you choose and start learning how to create some Java programs now that we at least know the basics. So that is the plan. So I look to see you in the next video to get started on our Java coding.